Alright, we will be converting from scientific notation to standard notation. We were doing just a while ago standard notation to scientific notation. So for us to change a number written in scientific notation to standard notation, we need to take some examples. Alright, so let's see some examples. So consider I have an example 5.4 times, let me put this in red so you can differentiate the power, and that power say is 6. Okay, we will write this now in standard form. This 5.4 is still 5.4. This 10 to the 6th power means times 10, which will be 6 zeros, so 6 zeros here. Okay, this 10 to the 6th power means this, there are 6 zeros, right? Now this 10 to the 6 is equal to 1 followed by 6 zeros. This tells you how many zeros there are. Okay, so now we proceed, and when we multiply this, we end up with 5, 4, 1, 2 plus 3 0 position, and that's our solution. Now let's explain this. Notice that there are 6 zeros here. You multiply this out, only 5 zeros stayed. Where did the other 0 go to? Well, it's right here being multiplied. It's so simply that when you multiply this out, that 5.4, this 0.4 is what takes on the space of the other 0. Okay, so that is how we write it in scientific notation. That is for a number like this. So we're going to try a negative one of them with a negative power. Okay, so consider that you have 2.35 times, say 10 to the negative 5 power. That is equals to what? Well, let's see if we can see a catch to this. When we had 10 to the 6th power, notice 5.4 becomes this. So therefore, if I was to have 5.4 on this side, this is what actually happened. I have 5.4 and I move it 6 places. 1, 2, 3, 4, 5, 6. That's my decimal point, and I add zeros in those empty places there. So we have 5 zeros now, okay, and the decimal point, and that's what we have there. Now consider this. What do you think will then happen? Pause the video for a while and then, okay, so I guess by now you should have catch the trend. If this has a positive and it move to the right, then since this has a negative, it must move to the left. So therefore, if I was to have 2.35 and I move 5 places, that would be 1, 2, 3, 4, 5. There's my decimal point. I add zeros. 1, 2, 3, 4. Remember the 5, 1 goes away, and then at the front here I can still put a 0 because that's just the whole number place, which is 0. So this written in scientific notation, in standard notation, it is now 0.1234235. That is how we write that in scientific notation. Okay, now another example is as follows: 4.26 times 10 to the 0 power. Now here you need to recall that any number to a 0 power is always equals to 1. So therefore there is no movement to occur here. So therefore this number in standard notation, it is still 4.26, right? So let's go to two main points here. If the exponent on 10 here is positive, move the decimal point the same number of places as the exponent. In this case, it will go to the right. If the exponent is negative, as in this one here, move the decimal point the same number of places to the left. You see that we went to the left, this one here went to the right. So this is going to the right, this is going to the left. So two main pointers for us to do converting scientific notation to standard notation. 2 points. If the exponent on 10 is positive, move the decimal point the same number of places to the right as that of the exponent. This is like this, right? Pointer number 2. If the exponent on 10 is negative, move the decimal. Decimal didn't come out there, so let me write it here. Decimal point the same number of places to the left as that of the absolute value of the exponent. That simply means if it's negative, consider a positive 5. I mean a whole number 5. So it's a positive integer, you just move that amount of places to your left hand side. Okay, that's what the rule. That's why we use the word absolute value for that one there. Okay, so let's try a few more examples. So if I have examples, if I have examples, 2.6 times 10 to the 7th power. This tells me I must move my decimal places to the right, 7 places. So I do that. I put now, so I put here 2.6, 7 places, 1, 2, 3, 4, 5, 6, 7. So that's 1, 2, 3, 4, 5, 6 zeros. So my answer will be 2, 6, that value. You don't need to be able to read the number, but that's our value. Let's try our next example. Consider that we have now 4.3 times 10 to a negative 5 power. What does that mean? This means we will move the decimal point to the left hand side. This will move the decimal point to the right hand side. So let's do that. So I would write the number towards this place here, because I will move towards my left hand side 5 places. 1, 2, 3, 4, 5. Here's my decimal point, and I add my zeros here, and just add an next 0 here for show the whole number place. So our final solution is 0.123443. That's a standard notation. So that's how you write scientific notation to standard notation.